This is the Amp Hour Podcast, recorded July 18th, 2011. Episode 52, Carnassial Chip Chemicals.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble from Chris Gamble's Analog Life.
And I'm Jeri Ellsworth from Portland, Oregon.
Hey, Jerry. Jerry's in the house.
Jerry's
Welcome.
in the
Hey.
house. Yep.
Good to be back.
Fantastic. I think we set a record this morning for the most amount of time taken to get an episode up
Yeah,
and
get
running.
up and running. Yep, that's right.
Yeah, we're just slack. I don't know what was going
I
on.
had some problems with the Google Plus stuff.
And
Yeah, we blame technology, don't we? Us Luddites, we have no idea how to drive this stuff.
And Jeri, if for people watching video, Jeri will be frozen the whole time. Unfortunately, video didn't work out for her, but maybe next time, so that's okay.
Right. And after all the complaints last week, yes, we are going to stick to electronics.
Electronics,
We think,
apparently.
Maybe. Kind of.
Are you sure about that?
Apparently electronics
I don't
are
know.
important, yeah.
Well, you know, it'll be electronic-y.
Yeah.
Is that even a word?
Electronic-y?
Electronic-y?
Electronic.
You know,
I
something's
think electronic
electronic.
is actually an adjective.
Is
yeah.
actually the... Right, yeah.
Yeah,
There's no need to put the Y on the end.
right.
We make it up as we go.
Right. So, Jeri,
Awesome.
you are here because we wanted to talk to you about transistors.
Ah, yeah.
And-
you must
and-
have seen
and
some
many
of my
other
new
things.
videos.
Yes.
We have seen your new videos. Very cool.
I have been watching the... So, if people don't know, Jeri
Well,
has...
there's one video, isn't there? I've only seen one.
Oh, he was sleeping. That's why, Jeri. She just posted one. Yeah.
Oh, right. Oh, sorry. No. Well, yeah, I only just got up. So.
What are you doing sleeping, Dave?
So some backstory here. About 5 years ago, I started on this quest to build transistors at home, Chris's favorite subject.
Mm-hmm.
And it took me about 3 years. Actually, it's been longer than 5 years if all my math works out here. But about 3 years ago, I made my first transistor. I posted a YouTube video about it and descriptions of how to do it, but it was kind of hand-wavy, and I didn't go through all the steps and show people. And for years now, people have been sending me emails about once a month or twice a month saying, "You faked that. I can tell. You know, there was a sleight of
Really?
hand trick." Oh, yeah, really annoying
Oh,
stuff.
goodness.
So I had a little bit of time on my hand after finishing a project, and I decided to set up the diffusion furnace and go through the steps again and try to make a little bit more advanced device. I'm hoping by the end of the week I'll have something, at least a NAND gate, or with a little luck,
Awesome.
a ring oscillator working.
Oh, nice.
So I've been building these transistors with just household chemicals and stuff that I bought off eBay, and I probably have, you know, in the actual stuff that I'm using to make the transistors, you know, maybe $1,000 invested or less.
Oh, wow. So,
Yep.
so less than a chip fab, you're saying?
Yeah,
Yeah, slightly less.
several magnitudes, I'm sure.
Right. But it does still require sort of specialised gear, doesn't it? I watched one of your videos and you had mention of like 1,000 degrees oven and all that sort of stuff.
So when I first started researching this, I got some books on semiconductor process. And of course, you get a modern book on process techniques, and they talk about ion implanters and plasma etching and all this stuff that's very expensive and almost impossible to do at home. And I actually started going out and acquiring this stuff. I have a plasma etcher, and I have
What?
an ion beam line.
I didn't know that.
I have a reactive ion etcher and stuff.
What? Chris, you haven't got one?
Well, I used to
Everyone
work on
should
those.
have
I used to work on
Come
those.
on,
at
everyone's got
my
one
old
of
job.
those.
That's awesome. So,
Yeah, this one's it's a TFE barrel etcher.
oh, nice.
It's more of an Asher, but
Yeah, so that's used for getting resist off usually, right? Mm-hmm. Yeah. That's pretty. How much did you pick that up for? I'm just curious about that.
I think it was less than $1,000.
That's crazy, man.
But I ran into a guy that worked at Fairchild Semiconductor. His name was Peter, and I'm not going to try to pronounce his last name. There's too many letters in it, G's and Z's and stuff like that. But he said he kind of took me under his wing, and he told me, well, back in the good old days, we used to do it this way and that way with much simpler equipment. So I've actually reduced it down to just a furnace that can go to 1,000 degrees C, or a kiln. You can use a pottery kiln too. I have a little tiny tabletop kiln that I've done the same work in. And a CPU fan for doing all the spin coating with some double stick tape on it so you can stick the wafer pieces down.
Mm-hmm.
And cool. I'm using vinyl stickers currently for all my masking steps, so I just cut out the patterns I want and stick it straight down to the wafer. And for etching, which this scares everyone because it has hydrofluoric acid in it, I either use art store glass etchant or this rust and stain remover that you can just buy from the grocery store called Wink rust and stain remover, which happens to have 2% hydrofluoric acid in it.
Oh, nice.
People always freak out about hydrofluoric acid because professors have put the fear of God into us that one drip of this is going to get on our skin and we're going to immediately die.
Right.
Well, they're talking about like full molality? Is it molal?
Yeah.
Molar? Whatever it is, the full strength stuff. That's what the scary stuff is. That's what I'm scared of, because when you work in a fab, that's what they talk about, spilling all over yourself. Even though that if that happens, anything
you use in a anything you use in a
sorted
fab,
you out, right?
Well, yeah.
Anything you use in a fab, they're going to go for maximum throughput. So if you need to etch an oxide off, they're going to use the strongest acid with the strongest concentration possible, so they can just run hundreds of thousands of wafers through per hour. At home, you can wait 20 minutes for an oxide etch with the rust and stain remover.
Mm-hmm. That's
awesome. About it. I mean, very little. I don't even do metallization. I'm using conductive epoxy for all the contacts and gates. And,
okay.
And that was thanks to Peter. I picked up all of this sputtering equipment and evaporation equipment, and I'm like, oh boy, this is going to be difficult. And he said, back in the 70s, we were experimenting with conductive inks. And so it works great.
So does this mean that you're going to use this higher end gear?
Perhaps,
or are you
someday.
just going to stick with the lower end stuff for this series of, like, the stuff that real people can get?
For this series, it's all going to be the low end stuff, because I have such a learning curve before I can start like bringing up an ion beam line or a plasma etcher.
You bend it the wrong way, and your neighbor walks out the next morning. They're like, something feels funny. I think I have a foot growing out of my forehead. This is so weird.
Yeah, you start accelerating ions and crashing them into your sector analyzer. You're going to start emitting a lot of X-rays.
Yeah, you just don't. I mean, yeah. But I guess if your neighbor's dog is a little too loud, or
neutered,
Actually, I have that problem, so that could be good.
There you go. Yeah, because some walls aren't going to stop those ion beams, right? I mean, depends on what it is. If it's the heavy stuff, it's probably going to get stopped. But if it's certain types of beams, you're not going to stop it with normal, clothing or.
Yeah, I don't know if ions would emit from the chamber, but because it's awful thick metal, they do have. You can extend electrons into the atmosphere through very thin metal windows. I think it's like titanium or something, but that's like super exotic stuff that they experiment with for medical applications. And so I think X-rays would be my biggest worry. So I should get some lead blocks.
So they actually go through the thin wall, do they?
Yeah.
Is that some quantum thing? Is that some... I assume that would be some quantum thing where it's, you don't know where it's going to be, so it can actually jump through the wall. It can actually jump to the other side of the wall, like quantum tunneling and stuff like that.
Yeah.
I'm talking out my ass here. This is
yeah, you are.
Physics.
You totally are. Yeah, you're talking about X-rays getting through a wall?
That's how quantum tunneling transistors work, isn't it?
X-rays get through a wall because of the wavelengths of the X-ray. I think. That's what I think. Maybe I'm wrong about that, too. The energy and the wavelength, I thought that's what gets X-rays through stuff.
Well, okay, the reality of every atom that we're made of, there's, the nucleus, which is very dense, and then you have all these electrons whizzing around, and the distance between those is massive. So, if you make a thin enough surface, electrons will go zipping through and won't collide with anything. Some will, but many will go straight through.
Yeah, actually, we are made up of 99.9% empty space, our actual bodies. All of our atoms are just empty space, really, mostly.
I
So,
actually
which is
experimented
scary.
with quantum tunneling, and I haven't achieved quantum tunneling yet. There's a process called light emission by quantum tunneling. I forget the exact acronym, but you make aluminum oxide layers so thin that it emits light when the electrons tunnel through to the surface on the backside. So if you have a transparent conductor, aluminum oxide, and an aluminum backside conductor, statistically these electrons will be on the far side of this oxide, and when this happens, it emits light. And it's kind of a cool process because depending on the voltage and field that you apply, I think it starts off with like a dull red glow, and as you increase the voltage, it goes up to a white light. But the efficiency is very low.
Yeah.
Someday I hope
That'd
to
be
make
very
that work.
cool, though. Yeah, that'd be awesome.
You should call Adafruit, and they'll make some clothes out of it or something like that.
I think
Right.
in all the literature, it seems like it's very dim. It's something you'd probably have to look at in the dark.
Yeah, that's really cool.
Sadly.
Though. Yeah.
So you guys were talking about the conductive pin a few weeks ago, and
Oh yeah.
Yeah, that's old. See,
Which
I
is
told you,
not
Chris.
new. I know.
You were
You're right.
talking about,
Yeah,
I
I
don't
know.
know where that news story came from.
I was so frustrated when people were sending me these links over and over and over again, like, ooh, a new pen that writes silver ink. Like, I had one when I was a kid.
I know. I'm sure I did too.
Well, I think you guys know I still am a kid. I mean, look at this.
Oh, yeah, you are.
Oh, the age is
Youngster.
creeping up on you there, man.
I know. Yeah. Good thing this camera doesn't zoom in. See the wrinkles?
Right, on that baby face.
Yeah, there we go.
Oh, goodness.
So anyway, I'm
so
very
Chris-
excited about doing all this home chip stuff.
Yeah.
I want to see more people go and experiment with this because, if anything, it's a great learning experience, and it's not too difficult. It's surprisingly easy. It takes me about, 12 hours to make a transistor that works, and about the same amount of time to make one that doesn't work. But
Yeah. But
most of the
surely,
time you're
Jerry,
just-
you
most of the
surely
time
you
you're
aren't going to... Well, we've got that delay audio thing happening. Real professional radio here, folks.
Yeah. Well.
We're a bunch of amateurs, aren't we?
Most of the time when you're making the chips, you're just waiting around for thermal processes to happen. So you just stick something in the kiln or furnace and just wait 6 hours.
Yeah.
Yeah. But surely, Jerry, you aren't going to buy into Chris's original fantasy
What?
that we'll all have chip maker machines and it'll be a revolution.
Here it comes.
Please tell me you
I
don't
know.
buy
We
into that.
we saw this coming,
I know.
Dave. We got
You
2 on
guys
1.
hyped it. You guys
2 on
poked
1.
me.
Yeah, there we go.
No,
Yeah.
I think it's going to happen eventually. Maybe not in our lifetime, but it's probably naive to say that it's not going to happen. It's
Sure. I agree, but yeah, it's not going to happen in our lifetime, probably, right?
yeah.
Because there's all those, there's all those really simple things like packaging, testing, and the fact that you can buy a 50-cent microcontroller that's already packaged, tested, and has a complete data sheet, and everyone else can buy it too. How do you
Can't
compete
argue
against
that.
that? It's one of those, And then the other argument Chris was making is that, but you can make your own custom chips. Well, wasn't that the idea of FPGAs? So really, it's pointless. I'm sorry, Chris. You lose again.
The nice thing about video, Dave, is I get to give you a death glare while I
Right,
listen to
and
you.
the good thing is I just totally ignore it.
And with my frozen video, it just looks like I'm pondering.
The frozen video is great. It's just Jerry sitting there with a
Staring at
finger
a chicken.
on her lips, like staring. Yes, are you staring at a chicken? What is that?
That's her
that
microphone
just covers up
cover.
my microphone.
Yeah.
All right.
So I like Jerry's argument, though. So what was it, Jerry? 50 years ago, people didn't think they'd have machines that made ice cubes in their home or something like that?
Yeah, but it's incredibly easy to make ice cubes. Come on, guys. You can't make you can't extend like that. You can't make the comparisons. We're talking about ridiculously small technologies to get any useful chip. It's just not going to happen.
I think the economies
As Jerry said,
of it
within
too.
our lifetime, right? And the economies of it, it's just pointless. It's
No,
not
I
like
think it
your
goes the other
original
way.
claim of a 3D machine, of a 3D MakerBot. That was your original comparison, and you've wimped away from that one.
I
from
haven't
day
moved
one.
away from that one.
You have. Come on, totally. I don't know. I'm not even
think-
going to argue this anymore. It's pointless.
It is pointless because we
You
don't know
guys
what
just
the
so
technology is going to be
massively
needed.
lose.
That's the problem. We don't know what the technology needed is going to be. So
No, I can tell you, if it follows the timeline for semiconductor manufacturer for the last 50 years, then it's going to be, the answer to that question is more advanced than the already unobtainable technology you can get at home. So, sorry, it's just not going to happen.
But you run out of headroom eventually too. So now they're going to like 450 millimeter wafers, right, or 12-inch wafers, and they're not even going to break a profit for like 5 years on a fab. So eventually they're going to run out and they're going to say, well, we don't want to make chips anymore because it's not economical, right?
Right, so the whole industry's just going to stop because no one's
I
going
don't
to
think that's
make
going to
money
happen.
out of
But
it.
I think
Exactly.
I think they'll push the chips that go into the iPad and everything else, and then eventually, I think that the small makers might not be able to get chips they need. So
Nah, it's a self-sustaining industry. Always has been, always will be.
Can I get a
a
second
self-sustaining.
to chime in here?
of course,
Go for
right.
it.
That's what you're here for.
Okay.
Yeah, that's exactly.
I just don't want to get into the yelling over each other match here, but
Oh yeah.
Oh, that's half the fun.
I know. So we look at. We'll take your argument, Dave, about the 8-bit micro a few weeks ago. As the technology gets better in our home, it may be 100 years out or 1,000 years out. Very simplistic devices are still going to have a purpose and a use, and on demand.
I totally agree. Yep.
And as these two technologies cross, as we can start manufacturing more complex stuff at home, things that useful as 8-bit micros will be possible. And then they could be integrated into your kid's toy that's 3D printed and has some kind of, built-in motor.
Quite possibly. But Chris's original claim was that it would happen, I think it was 20 years. Chris, was that the original? When did we first argue this? Like
I
back
don't
in
even
episode 1 or something, was it? I don't know. But it was like 20 years, and I instantly, my bullshit detector went off, and I just said no, straight off the bat. It's not going to happen in 20 years. It's not going to be a revolution. Would you agree with that, Jerry? 20 years is just too soon. You
That's
just
probably a
won't
little
be able to match
aggressive,
it.
but, in the 80s, I would have never
A little
imagined.
aggressive.
I would have never imagined I'd be carrying a computer in my pocket that I could make phone calls on. So it was beyond my thinking at that time that would even exist.
Sure, but surely you can't make the stretch that, it's taken, 50 years for semiconductors to get to the point where we can buy them and use them, so massively cheaply and have such huge integrated functions in them. And to think that within 20 years you're going to be able to make them at home using this massively advanced technology, I don't know. It's certainly not going to happen with silicon. No, I'll tell you that it's not going to happen with silicon, right? You've got to agree with that,
and now
Jerry. Sure.
There's Moore's law. Now we should make up Chris Gamel's law.
Ooh,
Gamel's law. Yeah.
the Gamel hypothesis,
Yes.
totally unproven. Yeah, one day,
And totally unobtainium.
One day I'm
going to
be like
unobtainium.
Ray Kurzweil, and I'll just be coasting on some predictions I made 20 years ago, and just keep on publishing and going on shows and everything else.
No, seriously, it's not going to happen with silicon, right? It's just it requires too many advanced manufacturing processes. It might happen using these new organic printed things or something like that. Perhaps that would, as far as I see it, that would be the only hope that you'd see something like the chip MakerBot within the next 20 years. It won't be using silicon. No way.
There's some issues with silicon, and actually this is a point that I want to bring up because so many people ask me about doing this. Like, for instance, it's drop dead simple to make solar cells at home with this same process. But the thermal cycles to do all of the processing of the chips make it not worthwhile because you have to put in, I don't know how many watts that is to run a furnace at 1,000 degrees C for 6 hours to do this.
Yeah,
The
That's not all
amount of
either.
energy. the amount of energy that little solar cell is going to produce, will never repay the amount of energy you put in to run this furnace, and that's where silicon really fails. Is the thermal processes are expensive. If you have a factory where you keep the furnaces up to temperature and you're constantly feeding wafers in there, you can get that cost per BTU down to fractions of pennies. But
BTUs, huh?
British thermal units.
I know that's the unit that's commonly used in the industry, but it's so archaic, really. BTUs.
I love it. I think it's great.
Yeah, I know.
I love the conversions too.
Granted,
It's like
I've used it.
It's like the stupidest number conversions too. It's like 6,500, 400, whatever it is.
Right. I love it. Oh, brilliant.
So-
and that's the problem with solar cells on your roof too. We've talked about this before. What's the cost benefit thing of having solar power on everyone's roof as opposed to having a huge solar installation somewhere? It's much more cost beneficial to have a huge solar installation than actually manufacture all of these smaller solar cells for roofs. So
I think that's a different argument. I mean, I agree with that, but
it comes down to a similar concept in the end, though. That it costs too much in terms of energy to manufacture these individual solar cells. You're better off spending the money and the energy manufacturing larger solar systems. Basically.
Yeah, the argument's been made over and over again that if it wasn't for huge subsidies, solar cells wouldn't be all that lucrative. Because it really is difficult to make crystalline silicon, and that's why there's so much research out there into polymers and amorphous silicon, and to make crystalline silicon, it's insane. You take sand and you throw coal into it, the thing that we're trying to reduce in the atmosphere. You melt this down to a huge slag, and then you dump it in acid and you dissolve it. And then this acid, you do a reaction with it that produces silane gas, and then you run it into these reactors that deposit out pure silicon on these long rods. And then you take that and you remelt it again, and then you draw it out into a boule, and then you zone refine it with these huge induction heaters.
Yeah.
The amount of energy it takes just to get to the point where you make your wafer is insane. And then you have to polish it and then do all the thermal processes.
Yep. And then you start on the actual manufacturing then you start on the printing processes, right?
Exactly.
It's crazy.
Have you guys ever seen the video of the slow motion capture of a boule being drawn out from a silicon?
I think I have seen that a long time ago.
It is so cool. They start with a little seed, and it's just like an old. I think it's the tip of an old one, and then they dip it in there, and then they rotate it really slowly, and they draw it out. It looks like the way you would get like cotton candy out, except it's
right.
amorphous silicon,
except
and
it's way cooler.
It's like thousands of degrees, So I'll try. I'll try and find that, link that in the notes, because. Man,
There's
it's
also
cool to
a
see.
good set of videos out there on the Japanese semiconductor industry that goes into the history of how the Japanese copied all the U.S. technology, and it's very fascinating how they made a lot of shortcuts for like drawing these boules out. Things like huge buckets of water with a hole in the bottom of it where the water would drain out, and there was a float thing that would follow the water as it drained out, and that would pull the boule up. Absolutely
Really?
Fascinating. Well worth finding it.
Yeah, I'll try and link that in too if I can find it.
Fantastic.
So I wanted to mention something.
So is that enough of... Oh, go for it.
Well, actually, I wanted to mention something because we were talking about organic. There was actually an announcement yesterday, or 2 days ago. There was
You're telling the story.
The world's first all-organic processor. You guys hear about that? There's a story on Elector.
No, I haven't seen it, no.
Yeah, it's on Elector.
You've got the link here. Let me check it out.
Yeah. It's 45
That's exciting.
on our list. Yeah. And so basically...
And it operates at a massive 6 hertz.
Yes, that's right. 6 whole hertz.
That's hertz, people.
Yeah.
Cycles per second.
Yeah, as opposed to gigahertz for standard ones.
Yeah. Or even megahertz, which is what the early micros worked at. 6 megahertz was a hugely fast micro back in the day.
Yeah, and so that's actually...
That was before you were born, Chris.
That's right. They were making that comparison. They're comparing it to the 4-bit 4004 from Intel.
Oh, right, yep.
And that was in 71.
What frequency did... What frequency did the 4004 run at? Jeri, come on, you're the vintage processor expert, aren't you?
Sorry, I don't know.
You don't know off the top of your head. Oh,
I wish.
fail.
I know
Oh,
a lot
come
of
on.
early calculators ran very, very slow. In fact,
Yeah,
I got some
think
of
it was-
these old 70s calculators, and I took little piezo speakers up to them and listened to the whir of the
yeah?
Oh,
processing.
nice, yeah.
It was very
I think
much
it was
in the
like
audio
600
frequency.
kilohertz. Yeah.
That's awesome.
I think it might have been as high as 600 kilohertz or something like that. I'm sure it was, in the hundreds anyway, not down in the tens of kilohertz for the 4004.
Yeah.
Although, because it was a completely static device, wasn't it? You could run them at 0 hertz. You could run them at 0.1 hertz if you wanted to.
Yeah, you flip it with a little switch. That's how you're clocking it.
You could actually. Yeah, I think all of the early processors, weren't they? Almost all of them were static devices. You could actually run them at.
No, a lot of them, like the
They weren't?
6502 was dynamic. You couldn't suspend the
was it?
clock.
Okay.
Yeah. I mean,
Right, I'm
that's
talking out my
how
ass.
they saved a lot of spaces. They just used the nodes between inverters to be storage
Right.
elements.
Okay.
Or in between tri-state buffers, I should say.
This is why I'm
So,
glad you're here,
there's-
Jeri, because I wouldn't be able to call Dave on that one. I'd have been like, oh, okay, whatever. Yeah, hey, did a great job, Dave.
Well, here's a fact of the semiconductor industry. It's much like the auto industry. There's this momentum going forward. Processors and semiconductor process has been done with optics and silicon for so long, and it's easier to do incremental changes to that process. That's why they've pushed lithography, well beyond what they thought was possible.
Oh, yeah.
It's easier to do that than develop some other technology, say with polymers. And polymer technology is kind of left to universities and little startup companies trying to be aggressive. And
Yeah.
so, of course, they don't have the funding of like Intel and other companies.
Yeah, true. Well, it's probably like the early days of the silicon wafers, right? It just takes decades to get, a decade plus to get these things to actually refine all of the processes before you can get to a point where you can make a usable part and stuff like that, right? So
Exactly.
it's
funny.
they're starting from scratch practically. They're going back to 1960 or something.
Well,
It's very, very interesting. I have
Well,
some.
not really. They have, but still, it's a very, when you've got a new technology, you can't just apply the old techniques that you use with silicon that you've been developing for 40 years, I don't think. Maybe I'm talking about my ass again, but I would expect if you start again with, some flexible polymer thing, then it's a totally different ballgame.
It's interesting is I have these books. So to develop my home process, I started going for older and older books, and I found books from the 60s and 70s where they talk about these
Nice.
processes that they tried, and it's very fascinating. Things that were tried were abandoned because at the time, they couldn't run 100,000 wafers per hour through a fab with that
Right.
technology. But you're seeing some of this stuff go full circle and come back again. For instance, metal gate on MOSFETs was abandoned in the 70s because of some limitations. And Intel in the last 3 or 4 years has switched back to metal gate because polysilicon and silicides don't work for down at these really small feature sizes. So now they're using refractory metals, all this stuff that was pioneered in the 70s but forgotten.
right.
I love it.
And now they herald it, too, as like the next big thing, too, right?
Oh, right, isn't it? Of course they do.
Hey, Jeri, I wanted to mention, too, about so you mentioned about using litho, too, and I saw a news story about Samsung hitting 20 nanometers, and I thought that was interesting because that means they're still using 193 nanometer wavelength on their optics. So that's their base wavelength, and then they do the rest with basically water. They play some tricks, and then they double pattern and everything. But I thought that was interesting because that means they're getting from 193 down to this 20 nanometers to get the smallest feature size, and that's the newest thing.
It's amazing what they're doing with optics. So for the mask sets, to do below the wavelength of light that you're using to do the imaging, like if you want to draw a rectangle, they're putting these serifs, just kind of like a font. So there's little dangly things that hang off of each of the on the main master mask that's at the full, the larger resolution. And then that's interacting with the light wavefront and twisting it around. And by the time all this magic happens with these wavefronts, when it actually strikes the photoresist on the wafer, now you have these interference patterns that are causing,
very cool,
far below your wavelength of light patterns to be imaged. And that's why it costs $1 million to have a mask set made. It's incredible. It's like every chip that I've worked on that's been 65 nanometer and these really tiny ones, everyone is just sweating bullets the couple weeks while we're waiting for the masks to come back. For sample chips. Did it really work? Because
that's scary.
There's so much processing. It takes weeks and weeks of computational power to figure out all these little serifs and features to put on to the masks.
Have you ever known anyone that was in charge of messing one up?
I messed him up.
Did you?
Awesome.
That's right. You heard it here first, folks.
Don't blame me. I'm just a contractor.
And now she makes videos.
Yeah, exactly. I don't work on back end, but I've messed up designs that have made it all the way into masks. And then you start scrambling and you do engineering change orders and stuff. Yeah, the good thing is, if you plan ahead and put uncommitted gates and different things onto your parts as a backup plan, you only have to change some higher level metal to fix a lot of these things.
Right.
So
there's almost a get out of jail cheaper card, not get out of jail free.
Yeah, and tens of thousands instead of hundreds of thousands.
Instead of hundreds of thousands. Nice.
So a little more difficult than adding a resistor here or there, right?
Exactly.
That's the stuff I'm used to.
One of my chips I designed, this was actually a set of cheap mask sets, but I fixed it out in the field because I forgot to reset a flip-flop and it would power up randomly and it didn't show up in my simulations. And so there was a test pin on there for JTAG, so I just toggled the test pin before my master reset and I was able to get in there and reset that flip-flop to the state I needed. So I was sweating bullets over that. I wanted to run to Mexico because there was so much money on the line.
Oh, my God.
Sweet.
Oops.
Speaking about companies and stuff like that, you mentioned before the show, Jeri, we were talking about warm, fuzzy feelings about companies, because you're going to be doing some work for a company very shortly who probably has one of these warm, fuzzy feelings.
Or maybe not, or not.
Or maybe not. Well,
so I've been talking to Intersil. Remember that old company from the 70s
from
and
the
80s?
70s? Yeah,
they make
Intersil. That's
transistors or something. Is that right?
See, unfortunately, no one knows what they make because they're one of these companies that got bought up by some big monolithic company and lived under the umbrella of this large company for a while and kind of
vanished, really.
Languished
from the mindset.
Is that the right word?
Right? I don't know.
And now they've been kicked out and they've spun out on their own, and now they're struggling to be seen because no one thinks to design in Intersil parts. We all have our warm fuzzy feelings about National or Linear Technology
or Maxim, who everyone's famous for having a warm fuzzy feeling about. But in that case, it's
No
once
comment.
bitten, twice shy. But yeah, I mean, I wouldn't think Intersil. I just get the impression, they're that 70s company who got bought up, and they don't really do anything. It's just a shelf company now. That's the industry slant that I get from Intersil. So they need some good marketing, I guess.
Yeah, so I'll be helping them out doing some videos, and we're going to do a really cool project. Maybe I should keep it secret until another...
Definitely keep it secret. Yeah.
I haven't signed on the dotted line that I'll be doing it yet, but it looks like it's going to happen, and it should be a lot of fun.
Yeah, that sounds like fun. So if anyone else has got a warm, fuzzy feeling out there about companies, tell us. Leave a comment. Which company do you have? You just don't touch because you don't really know why, or either you don't touch or you use all the time because of just a warm, fuzzy feeling that engineers get, really.
I think some companies just fell into this on accident. I don't know why I feel so strongly about Altera. They've never given me any love or anything, In fact,
Right.
they've kind of ignored me a lot, and
Yeah.
but yet I keep designing, or for years I've designed their stuff in.
Yep.
Yeah, got to get them young. That's the problem, and that's why they give kits to schools, and it's smart when they do, donating to
Yep.
education and everything else. It's damn smart because you grow up learning about something or using something the first time, and you just keep using it. I know I've seen
And
that
I
before.
wonder if that's the reason why a few companies are trying to jump on the the hacker maker bandwagon
Oh, yeah.
now with their chips, with their micros or stuff like that.
And it's brilliant if they do.
Whether or not they actually understand that warm fuzzy feeling that people grow up trusting some particular brand or something like that. If you grew up with your first micro was a PIC or something like that, you're going to have a warm fuzzy towards PICs for most of your career, unless they piss you off in some way, really. It's the same thing with other companies, and that's how PIC made their big thing, I think, is that they started out, they were the only ones who would, really do really entry-level micro sort of stuff. The others just didn't care about that sort of thing. So
I think you hit a nail on the head there, Dave. These companies should be giving out developer kits and free samples like it's candy.
Oh, yeah.
Yep.
Yeah, I know. You think about
Absolutely.
it, we might have talked about that on here before, but you think about how much they spend on, advertising. At a certain point, it's just more economical to give this stuff away to people that will use it, and then they're going to tell their friends.
Or advertise on our show, sorry.
Oh, don't
Waving
forget
my
that.
hands here. No, they must. Yes, no, advertising is important, but it's got to be at the right end of the stick.
Well, we can hand out these kits. I mean, who cares? We'll hand them out to people.
Awesome.
Yeah, but I really do believe that. I think at a certain point, giving kits to people, get them in the hands of people who will either learn on them or develop with them.
Yeah.
That's money.
Or maybe
It's a
maybe
big
not
deal.
even develop anything with them. Just that like, hey, this company went out of their way and gave me something. I couldn't use
exactly.
it, but
Yep.
That's true. That's that's a very basic human thing too. Like when people are selling stuff, they always try and give you
Yep.
something, even if it's something silly like a pen, because then you feel obligated at some level, which is weird. But
Hey, well, I'll tell you what. Back before your day, Chris.
I'm so young.
Data sheets, data books were the big thing. If a company gave out that, some companies were so strict on giving out data books that you just wouldn't touch them. Whereas the ones that would give out the data books like candy, or they'd sell their data books in the local stores and stuff like that, you ended up using their parts, because this was, pre the internet and, all that sort of stuff. So you really had to design. The only info you had was in those data books. Yeah. And if you've got, national data books on your bookshelf, well, you're going to be using their parts, right?
yeah.
And it's a similar thing these days. So
Wait, what's it?
I
oh,
think
you
it
mean
still
with parts
holds.
these days, not necessarily
And
data. I don't need a data book personally.
with kits and things like that, yeah, the companies that give their stuff away and get their stuff in the hands of people are the ones who will ultimately win, I think. So, yeah, and even to this day on my bookshelf here, I keep TI and national data books, because they're the ones who, freely, they're the easy to access, easy to get data books back in the old days. And I, even to this day, I still have a warm, fuzzy feeling about those companies, because I happen to get their data books. So I think it's a big deal.
there's some kind of nasty things about the semiconductor industry that I don't like, as far as like trying to get information. There's the in-between sales reps between these companies that you have to interface with all the time to get a data sheet sometimes, or get a sample part. And it's all about,
volume.
getting there.
It's all about volume.
Right.
And we're not talking about how loud Dave's talking today.
No.
Talking about how many parts you set, or how many parts are going to be designed in your products, right, Jerry?
That's the
exactly.
big $1 million question. Yeah, they always ask that. What's your volume? What's your production volume?
And I've worked for companies that have that mentality where, I've asked them, well, why don't you put these parts out so people can get them? And they say, oh, well, we only want to go for the top tier companies like Sony's and stuff like that. They want to get the million chip sales, and they don't get it that engineers like us, will call out these parts when we go work for the Sonys and the big companies.
That's right.
Yeah.
And it's partly laziness and maybe lack of resources they want to throw at supporting, the questions they're going to get by putting these parts out there.
Yeah, and to be honest, that's kind of the old model, right? I mean, that's kind of how they always had to do it, because if you have 10 salespeople, or 10 reps or whatever, then you can only, have them cover, if they get 5 accounts each, that's 50 accounts, right? So they're going to get the top 50. Yeah. But the nice thing is that you can hire nice people like Jeri or Dave or the Amp Hour, because I don't do videos myself, but and you can do social media type stuff, and boy, if that's not a plug, I don't know what is.
Yeah, exactly.
I think
this
sales
comes
reps
up on the.
So I think sales reps, should go the way of the dodo. I mean, that's just so, outdated.
Yeah, it's so archaic. It's just in today's, when everything's available online, and here's the rant I wanted to do. It comes up on the forum all the time. People are pissed off at these companies who make you sign an NDA to get a freaking data sheet. Give me a break.
Are you talking about unreleased?
I'm going to boycott not only that part, but I'm going to boycott your freaking company because you pissed me off.
Yeah.
Engineers are fickle. Don't piss us off like that. Say NDA to get a bloody data sheet.
Are you talking
waste our time?
I've had to go through like a local rep who will just give me the data sheet on the sly because they also hate the thing that you have to sign an NDA just to get the data sheet. So here it is. Psst, psst, buddy, hey,
Want to buy a data sheet?
Want to buy a data sheet with the trench coat and the whole... Yeah, it's just bullshit. Give me a break. Those companies deserve to fail. End rant.
So
what
Dave
else
just
we got
made
on
an
today's
argument
list?
that we should keep sales reps around.
Well, yeah, that's about the only good thing I've found.
Okay.
So,
Are you talking about companies that, is it like for an unreleased part? Is that what you mean? I don't.
No, these are just regular parts, but they just deem them to have proprietary information in them or some crap like that,
But you could get the data sheets online or no?
No, you can't. There's a link there that says download data sheet, and then, you hit it, and then it says, you have to sign an NDA first,
Sign an NDA,
like
not just sign
off.
up for the site?
No, it isn't just sign up for the site. No,
Wow.
You've got to sign up for an NDA, or you've got to contact. Some aren't like an NDA, but you've got to contact them, and then they will suss you out whether or not you're worthy to have their data sheet.
You're talking about the sales funnel. Yeah.
Yeah, right, yeah.
You're in the funnel now.
Yeah, I'm sucked into the
You get a
funnel. Well, I
funnel
just
right up the
don't enter
keister.
the damn funnel.
That's a great description
You
of
can
it. It
shove
really
your
is.
funnel right up your backside. That's what you can do.
That's the one that's what they call it, if you didn't know. That's what they call.
Oh,
Yeah,
Like,
yeah,
that's
the
a real
sales
term.
funnel. Yeah, yeah, it is. Yeah, it's a real wank term. Yeah.
Yep.
Yeah. Speaking of that sort of stuff,
Oh.
very similar thing, which somebody mentioned when I did the review of the latest Fluke 87 meter. They actually gave me a pre-production meter to actually review, which was awesome, which fixed the GSM issue. Anyway, I noticed that they had removed the patent marks off the back of the meter. If you own a Fluke 87, if you have a look on the back, it has, this is covered by X patents, and it had like two or three patents on there, but the new meter doesn't have it at all. They've actually removed them. And somebody mentioned that you can actually get fined for putting expired patent numbers on a product. You can get fined like $100 per item or something like that. So if you sell, 10,000 multimeters, you can be, you can pay like $100 per item as an infringement kind of thing. So, and I've actually had that confirmed that it's not, it's not into law, but you can actually get sued for putting fake, expired patent marks on things. So companies have to be careful. I'm not sure how I got onto that, but anyway.
I wonder
Companies.
how that applies for patent
weird.
pending. Everyone puts patent pending.
Everyone puts patent. No, this is like expire. Yeah, this is when the patents come to the end of their term. Like, these are probably old Fluke patents, 20 years old or something, back in the 80s when they actually when they were leading in multimeters and they were doing all this innovative, ASIC stuff and things like that. So,
Do either of you guys have patents?
yeah, it's
though?
interesting.
I don't know if I've ever asked you that. Dave.
I've got one technically, yep, and I had another one that was a patent pending as well, but yeah.
I went through the process,
You
but
know me and patents.
none of mine were issued. It's a long, drawn out,
Right.
annoying process.
Yeah.
Yep. I've got one that was issued and one which was a patent pending, which my brother-in-law, who's a patent attorney, talked me into. Oh, you've got to, please, I can write your patent for this. Oh, all right, I'll humour you. You know, write me a patent for it, and yeah. Oh dear. Never again. Hate patents.
So
Unless I come up with such a cool, massively innovative, industry-changing idea that, yeah, maybe.
So I ran into a bunch of Fluke guys up at a pinball show in Seattle, and they set me up with a bunch of Fluke gear. I can't remember the number off the top of my head, but it's a really nice meter.
Yeah, I saw
They
that
said-
in your video, right?
Yeah, they're like, whoa.
Oh, you've got the Fluke 289, I believe, there, Jerry. I saw in your latest video.
Sounds right. They're like, well, they said, we're tired of seeing you use these $2 voltometers.
Right.
And I told them, I said, well, I'm still going to use the $2 voltometers because, I don't want people to think that they have to have an $800
Yep.
meter to do, something where 10% accuracy is fine.
Yeah. Yeah.
That's what happened when I first started my blog. I was using a Fluke, actually. I was using a Fluke 87, but the German company came along and they just went, well, we don't like you using Fluke. Use our meters in your videos. Here's an expensive, $800 Gossen meter. Well, thanks. Okay. I'll use yours in the videos. I'm a bit of a whore that way. I'll use the most expensive bit of gear I've got on video. I don't need to make a statement that, because I say it all the time, horses for courses. You use the tool that's, you use a tool that's right for the job and you can get away with using a $10 meter if you want.
Jerry, you should have turned to them and been like, I made these in my kitchen. 10% accuracy, probably going to be enough.
Good enough.
Exactly.
Man, I want to see. I had a couple other questions for you about those. Where did I put these? So you said I wanted to ask about how you did the masking. You said you did that with vinyl tape. Would you ever do that with photo at all? Like any kind of photo lithography or anything like that? Even real?
In the past I experimented with that and had some failures. There's a lot of steps to doing photo processes on semiconductors because the surfaces get a little funny sometimes. Sometimes you have to grow oxide over the bare silicon, so it's
So it'd fall over, right?
Yeah, because silicon's kind of hydrophobic and bare silicon.
And
So
that's a great word. I'm sorry, hydrophobic. That's just it's a brilliant word. Word of the day.
And so I didn't have a lot of luck. I tried a little bit this weekend and didn't have much luck with it. The bottle of photoresist that I have says shelf life 6 months, and it's probably 3 years old. So that could explain part of the problem. So I may have to regroup and reorder.
It'll still work, won't it? Just takes a bit longer. Is that the?
I probably.
Is that the deal?
I don't know. The traces just fell off, but chances are it was 3 years old when I bought it. So
yeah.
So yeah, the vinyl sticker actually works very well, and you can make transistors that work with huge channels on them. And people often ask me, why do MOSFETs at home? Why don't you do bipolars? But actually, bipolars are a little bit more difficult at home because you need a furnace that's very accurate because you're doing a diffusion to make your emitter and collector meet the base in the middle. But you can't overrun the two or you'll have no base left. Mm-hmm. And that's a thermal process, a thermal plus time process. And it's much easier just to grow oxides for a MOSFET and just look at the color of the oxide to know that you've got the right thickness. That's
I really like that curve tracer you used too. I thought that thing was awesome. The old school curve tracer.
Oh, yeah. I love curve tracers. Yep.
Tech 575.
Yep.
It's
classic.
Great. It's great because I can just hook anything up to it I want, like a power supply, and drive the gate to a negative rail way farther than it's the 575's rating. I don't have to worry about it because it's all vacuum tube.
Take that.
Tubes. And it actually warms up the shop in the middle of winter, right, Jerry?
Exactly. But the furnace does a good job of that.
Right, yeah. Very inefficiently, but no, well.
So
bonus.
So we've been doing. Jerry, have you listened to the latest episodes? I remember you said you were listening to older episodes a while back. Have you heard any of the most recent ones?
Probably within a week or two.
Oh, okay. So yeah, we started doing This Day in Nerd History. Have you heard that one? That new segment? Okay. So we actually have one. We have one that's kind of relevant today. So we talked about the 4000.
Yeah, we do.
The 4004 is we talked about how the
4004
4004 or 4004.
Here we go again.
4004.
Yeah.
Triple
Okay.
five.
Triple five.
Yeah, the 8088,
80.
not the 8088, you know, and it's the 8080, not the 8080. So, yep. Sorry, Chris.
Whatever, man. To each their own, you know. That's fine. I don't care.
All right.
Anyways,
4004. Yes.
4004. Today in history, 1968, Intel Corporation was incorporated. So that was
That's pretty huge.
yeah. And interestingly, I didn't know this. Andy Grove is apparently a Hungarian immigrant. This is just the thing I found about it, but he was the founder of Intel, and he's a very big advocate for the industry still. And you know, rest is history from there. 4004 or 4. What do you call 4004? And then they went on
4004,
8008, and everything else. And
yep.
yeah, you know.
Now you're learning. Lots of good engineers come out of Hungary. It's lots of good software programmers. I think we talked about this before. There's the Hungarian method, which is a method of programming.
I've never heard of that.
Which comes out of.
We talked about that?
Yeah, I think you could. Yeah, I've mentioned it somewhere. Oh, maybe it's on one of my live shows or something like that. I mentioned it perhaps, but
Care to expound upon it?
And Charles Simonyi, if I pronounce that correctly, who's if you've heard of him, if you follow the history of Bill Gates and Microsoft, he was their key software architect back in the very early days, and he did Windows and Office and all that sort of stuff. And he's from Hungary, I think. So, and he wrote a seminal paper on some programming methodology or something. So that's apparently why Gates hired him, and apparently it didn't work that well. But he was a shit hot programmer anyway, so they went with it.
Yeah.
Talent overcame theory there, I think. So anyway, lots of good engineers come out of Hungary for some reason.
So one of the first products that Intel made was dynamic memories, which were
it was,
and they were able to make more dense memories because they came up with this technique of annealing the oxide layer or the layers over the metal. If I'm maybe over the polysilicon to smooth it out so there wasn't sharp edges. So that was like their big thing and gave them a huge advantage over all the other chip manufacturers of the time.
Yeah. I can't imagine. So you were talking about how I figured was it Peter? That was your mentor's name? Mm-hmm. I'm
sorry, Peter, if you listen to this, I cannot say your last name.
It's okay. It keeps him anonymous. That way people don't come bug him they can come bug you now about processing tips instead of him, right?
Exactly.
There you go.
Yeah.
So I used to work in a fab, and I talked to the guys there, about, old war stories and stuff. And they told me about just like how the processing used to be there and just how incredibly noxious the entire environment was. They'd be like these open etch chambers and everything else.
Nice.
I just can't even imagine like back then, like you see the first transistor too, that was it Schottky that worked on that and a couple other guys.
Barden, Shockley, and who's the third dude? Come on.
Bardeen?
Thank you. Bardeen, yes.
So, yeah,
who didn't like each other, apparently. There's the famous photo of the three of them
punching each other,
standing there over the microscope. They stand there over the mic. One of them's looking in. I think it's Schottky or someone Bardeen looking into the microscope, and the two others standing there. Apparently, that's the only time they wanted to be in the same room together. They apparently hated each other or something like that. So the story goes. Anyway, a bit of trivia there.
That'd be funny if that was... You ever seen that Far Side comic where they talks about like scientists playing jokes upon each other, and they show like the guy dropping acid onto the other scientist's neck?
Right. No, I haven't seen that one. Cool.
Jerry, you can do that once you're done burning yourself with hydrofluoric acid, right?
Exactly.
Exactly.
Watch this. I'll play
Great.
this trick on Chris. Just get a flight to Cleveland, of course, in order to drip acid on my neck. But
Yep.
what was that? I don't even know. Oh, just the noxious environment. Yeah, it was. I mean, it seems.
Well, a lot of those places are Superfund sites, and for those that don't know what a Superfund site is, that's where the U.S. government comes through and cleans up all the toxic chemicals they dumped right into the soil.
It's amazing.
So, rumor is that the old Fairchild plant somewhere in Silicon Valley is just like all boarded up around it, and it's completely toxic.
Glow in the dark, huh?
Exactly.
Yeah, well, back in those days, there was no occupational health and safety. There was no EPA. There was, you just got away with anything, really.
Maybe
These days, everything's so,
Maybe Andy Grove started Intel just as a front, and now with all the radiation and chemicals he's exposed to, he's actually a superhero.
I was going to say he's a superhero.
With a superpower.
Silicon Man.
Yeah, the incredible nerd. Our hero. Yeah.
Fights for truth, justice, and the nerd way. Oh, I love it.
So, guys, I listened to a podcast a couple weeks ago where you were debating the advantages of software-defined radio.
Yes.
Did you want to cover that real quick before we run out
Yeah,
of
we were
time?
talking about you.
Oh, I don't know. Yeah, very, very quickly if you want.
Yeah. So you guys were debating, why do software-defined radio?
And I totally botched it.
I wanted to jump out of my vehicle as I was listening to that.
Yeah.
Well, my comments were based on no knowledge at all of software-defined radio. They were just based on, things just things in just hunches, really.
People were asking on Twitter too. Did you hear our crankshaft camshaft mix up? They thought that you might have actually crashed your car when you heard that one.
Who crashed your car when you heard that? Yeah.
I saw those comments. Funny.
Yeah.
Anyway, software-defined radio. Tell us.
So I'll try to keep it brief since we only have 3 minutes. But
Yeah.
so for years we've had crystal sets and regenerative receivers and super heterodyne receivers, and they worked great, and you could tune any frequency you wanted with them pretty much. But in the last couple decades, we've had the advantage of high-speed digital signal processing, where we can eliminate a lot of the analog circuitry and do it mathematically inside of a DSP or a CPU or an FPGA.
FPGA.
And the huge advantage of doing this over, say, a super het receiver is there's a lot of advantages, but one is that once you get everything into the digital domain, there's very little phase errors. There's no phase errors that you have to deal with. So in a lot of ways, you can do processing in a very a perfect way. And some other advantages is like
Perfect way.
well,
Sounds very utopian.
all right, maybe I'm not describing that right, but
No,
more
I
precise.
understand what you mean.
Efficiently, yeah. There's less physical effects in order to deal
Well,
with.
is it more, let's say from a power perspective, which would be a more power effective approach?
Digital.
There's a huge amount of processing. I assume a huge amount of processing required, DSP processing. Well, when I say huge, not, a room full of DSPs, but, a fair bit of crunch in there.
All right, I'm going to have to pull some of this out of my behind, but
That's what we do here on the Amp
That's
Hour.
right. We've done
Exactly.
it for an hour so far, right?
Yeah.
Since I can't qualify how much my FPGA is consuming as far as current, but so in a super het receiver, you almost always have a front-end amplifier, which is a smaller amplifier. And then you go into a mixer stage. And then the following stage, you have very steep filters and very aggressive filters. And your intermediate frequency has to have a very, very strong amplifier. And so a lot of times your intermediate frequency will be, or intermediate IF amplifiers will be consuming tons of current to be able to drive all these crystal filters.
Yeah, that's a lot of bit flipping, or a lot of flipping, right? Or moving around at least.
With software-defined radio, you don't have to have a front-end. You don't have to have a front-end amplifier at all. Sometimes you don't even need to have a front-end bandpass filter. So there's very little
Right.
insertion losses for things like filters. And then when you do direct conversion, you go directly from RF down to a very low intermediate frequency. So that means that you're using amplifiers, which are just off-the-shelf op-amps and instrumentation amplifiers that work in the kilohertz range. So your amplifiers are simplified, and your filtering is now closer to the analog frequency. So you do everything with R's and C's, so just RC filters. So you don't need to be consuming all that power. So now the question is, once you digitize that and get that into the FPGA or CPU or whatever, does the CPU do that efficiently?
Take more than, exactly.
And
I don't know, it's an interesting question. If somebody knows, let us know. If you've got some numbers on that.
There's different ways you can do the processing in the FPGA. So there's more aggressive ways. The way I did it in my video is I did it a more aggressive way where I did a Fourier transform and I converted all this data into the frequency domain. Then I did my work on it. Then I transferred it back into the time domain as audio. So you can actually do, I think it's called phasing. So you can do this digitally, and it's a simpler way to do the processing, but less flexible.
So do you have to do it in the frequency domain, or can you do it still in the time domain as you actually capture it?
You can do it in the time domain or frequency domain. There's processes.
Right.
But as you start making fur filters with multiple taps, it becomes increasingly difficult to make really good fur filters. So at some point, there's a trade-off to go from time domain into the frequency domain.
Right.
And
got it.
So, So, and there's some other advantages, too, as far as you're not throwing away as much information when you're doing the down conversion. So, with a superhet receiver, you're throwing away 50% of your information. And with a IQ, it's what is called a in-phase and quadrature direct conversion receiver, you get twice the bandwidth to work with and twice the information. So you can do image rejection inside the FPGA, and you don't have to have these aggressive filters. Nice. And I don't know if that's making sense. I'm trying to condense down a very complicated subject into 3 minutes.
No, that makes sense to me.
I think it's a tough thing to do because if people know about baseband shifting, that's a big jump right there, right? I mean, you have to if you try and step back and say, oh, well, you multiply frequencies and everything and it shifts down to baseband. That right there is a huge concept in itself. But if you say, okay, you do some magic, not magic, but you do something, and then you're processing more audio and you're doing it in the digital domain, then it's like, okay, well, it's kind of hand wavy, but it'll probably get you to the point where you say, this is the important part of radio, learn this later, and let's move on.
Right.
It's kind of sad. I made this video. I put a full month into this video. I mean, really hard work to make this thing. And my time limit was...
You work too hard on videos, Jeri.
I know.
I'm telling you.
I know, but it's fun.
As a fellow video blogger, you spend far too much time producing video.
Well, the part of this video is a middle finger to a certain company that some of their engineers
that's awesome, then.
treated me really badly during an interview. So...
Take that.
Fantastic.
Yeah, I pretty much just came back and made the circuit that they were super critical about.
That's so awesome. I think that is so great. I hope
up yours.
Yeah, I hope they watch that and they're like, oh, wow. I hope they don't say, well, we should just use that then.
It's kind of sad. I put all this work into it, and it's kind of lost on a lot of people. They don't quite get the coolness factor of it, which is it's a little disappointing. Right. Like the simplest things I do sometimes, like gluing a Nintendo and a video screen to a purse gets all the attention, and then these really cool things get no attention.
Complex, Well, that's the thing. Everyone's idea of cool is different. That's just human nature. There's nothing you can do about it. Some people like some of my videos, some hate them. It's like...
Well, I think it's more of a...
Can't please everyone.
People... I mean, it's almost beyond to the point where they don't understand the significance of it, right? I mean, there's...
Yeah, but even what should they? And that's the other question is, should they have to understand the significance? Some people just don't care about that particular subject or thing.
Should
Even if it
they's
is
a loaded
significant,
question.
they just couldn't give it to us. Yeah.
But the amp hour listeners would certainly think it's interesting and get it.
They would be
'Cause
intelligent
they're
enough to...
higher caliber than the average Joe.
Well, I mean, and
Right, than the average YouTube commenter,
Oh,
right?
that's true.
oh my,
That doesn't take much.
yeah. I mean, I've been saying
just
for a while
slandered all
too
YouTube
that
commenters.
if people haven't seen, go to Jeri's Jabber channel. That's where the real good stuff is, because she's actually showing how you're making it instead of just the result video. I mean, I really like the Jabber videos better because it's, even if you try and fail something and you tape that's is just as good to see, I think, Jeri.
Well, my other channel, I also try to show how it's done, but it's more perfect. It's like I leave out all the failures.
It's the cooking show, right? It's like the
Oh, right.
and,
Okay.
and so we put it in the oven, and then 35 minutes later, it comes out looking perfect, like this, right? That's the cooking show thing, That's,
And it's interesting. Some people get really pissy with me if I put that stuff into my regular channel. It's like, well, you didn't actually show the completed project. You only showed part of it, and it was like really frustrating.
You fell for their trap. You made the mistake of listening to them, Jeri.
I know.
And then you spun off a new channel.
I think the new
You've
channel's
gotta
great. I
give
think
them the
it's
middle
great.
finger and tell them to stick it.
Yeah.
I think it's working. I mean, I see where some people are just passively interested in the final result, and they don't want to know, how many times I melted my bones with hydrofluoric acid.
Did you do that? I
Right.
heard about that. Jeri Ellsworth, now without hands.
Exactly.
Mutant.
Yep.
2 nubs up.
Should we end the show on that?
I think
We're
we
already
should.
6 minutes over.
We're a bit out. I
Yeah.
did go and check. I don't know if people could hear me leaving or see me leaving, but our video did cut out, so you get about 15 minutes of just we'll just put Jeri's screenshot up there and just hold that for the rest of the show. But yeah, who cares? We appreciate people paying.
I don't think anyone watches the video anyway,
Thanks for
do
being
they?
patient to people who do watch the videos. Whatever. We appreciate everybody who watches or
And
listens.
we do have a proper Amp Hour YouTube channel now.
Yes.
So if you want to subscribe to the Amp Hour YouTube channel, that's where the videos will be. I will not be uploading them onto my channel now because, well, I think it just annoys people.
Yep, I agree.
Oh, don't listen to them, Dave. Don't listen to them.
I'm
there
not going
we
to
go.
listen to them. But you can't have it on YouTube twice. There you go. It's got to go in one location. So
Fair enough.
I think it's better if we just have our own separate channel. And people can subscribe to
Dave,
that
you
if they
shouldn't
want
start
to
a second
or not.
channel, Dave.
No, shouldn't start a second channel.
Man.
But
Jeri,
considering
you gotta
that
come
this
back
is
more
a
often. I
joint
make fun
venture,
of Dave more when you're here, I think.
right?
Bad influence.
And it always fails.
Yeah, well.
It's always an epic fail.
Well, thanks
You'd
for
like to
having me
think
on,
you try,
guys.
but-
It was great and
It's
fun.
always a
And
blast.
Thanks for coming.
sorry for walking over the top of you guys so much.
Walking over the top.
No, that's the whole idea.
Okay.
All right, well.
And of course, I win the chip maker thing.
Oh,
To be
Because
continued.
it's just garbage.
To be
Sorry.
continued.
It's just not going to happen, dude.
Yeah.
If I'm doing it at home, it's going to happen everywhere.
Yep.
Right. Thanks for joining us, everyone.
Thank you.
Thanks, Jeri.
Bye.